These are pre-lab discussions for experiment 3, empirical formula with compound. What the purpose for this experiment is to determine empirical formula, which is a simplest chemical formula for zinc iodide. So I'm going to cover this and make sure that you can do calculations for the experiment. So you could answer the questions on the pre-lab assignment, and you could do calculation. I would use like a sample problem. Let's say you have this problem given. What's the empirical formula for a compound that is composed of 69.9% iron and 30.1% of oxygen? Our first step would be, if the percent is given, we are going to change the sign for percent to gram. By doing that, we are assuming we have 100 grams of the compound. So 69.9% of 100 grams would be 69.9 grams. And also for the oxygen, we change that to grams, so 30.1 gram of the oxygen. When we determine empirical formula, we want to know the lowest ratio of the number of moles of elements in a compound. So in this problem, after I assume that I have 100 grams of the sample, my next step would be to change the grams to mole for each element. So to convert the gram to mole, I use the periodic table. I find the mass for each of the elements. So for iron is 55.85. I multiply 69.9 grams of iron by this ratio of 1 mole iron is 55.85 of the iron. So when I multiply that ratio and I get the number of moles for the given mass of iron, I do the same for oxygen. Remember, oxygen is a diatomic molecule. So you would, if you were trying to find the number of moles of oxygen gas, you would divide that by the molar mass of O2. But when you are doing empirical formula, please make sure that you use the atomic mass for oxygen, which is 16. So we have 30.1 gram of the oxygen. You multiply by the ratio of 1 mole oxygen is 16.0 gram of oxygen, and you find the number of mole of oxygen. If we had a whole number for the iron and for oxygen, we were done with finding empirical formula. Now we don't have the whole number, so we have Fe is 1.25 and oxygen is 1.88. Our next step would be to find the lowest ratio. I would divide both numbers by 1.25. In this case, it's going to be 1.25. So I divide both numbers by the lowest number, which is number of moles of iron. So obviously 1.5 divided by 1.5 is going to be 1. And the value for the 1.5, 1.88 divided by 1.25 is going to be 1.5. So I show you here, we have the moles of iron is 1 and moles of oxygen. So we have Fe1 and O 1.5. So in this step, I have the lowest ratio, but the lowest ratio is not allowed to have a decimal number. I mean, no fractions. I have to change this to whole number. So I have to work with these numbers to change them to a whole number. So I have to be simplified and has to be changed to the whole number. If you get a ratio of 1 to 1.5, it's easy. You multiply both of them by 2 and you get Fe2O Fe2O3. Fe2O3 shows the lowest number of moles or the lowest whole number ratio, and that is known as the empirical formula for iron oxide. So we have the empirical formula. We just move to the so now, if the number is not 1 to 1.5, let's say you have 1 ratio of 1 to 1.33, then you multiply both numbers by 3 to get to whole number. That would be 3 and then 4. And these numbers, if you find a number, experimental value, when you're dealing with like experimental value, if you find the final answer like is 1, and then the other one is like 2.08, okay, 1, 2.08. Then you don't have to multiply this by like a 70 in order to get a whole number. So you're just going to round up and say this ratio, you would accept it as like 1 to 2 ratio, and then you write your empirical formula. So the ratio, when you find the lowest mole number ratio, it should be within a 0.1 from each other, or 0.1 from the whole number. And if it's more than that, then you have to multiply by 2, 3, 4, 5, or a different number until each number of mole is close enough to a whole number that you can round off. But if the difference is less than 0.1 or is 0.1 or less than 0.1 from a whole number, you can round it up before you multiply by any numbers. What we have in this experiment, we are going to find the empirical formula for zinc iodide. In order to find the empirical for zinc iodide, experimentally, you are going to find the mass for reacted zinc. So you need the mass for reacted zinc, and you need the mass for reacted iodine. How would you find that? That's like, those are the result of the experiment that you will be doing. So you are going to watch the video for the experiment and find out how much is the mass of the reacted zinc, which is going to be different from the total zinc you start. It's going to be different from unreacted zinc. So pay attention to the video. And also, I wanted to emphasize on getting the lab manual as soon as possible. If you don't have it at this point, it's a little too late. Please make sure that you have the lab manual. You read the experiment from the lab manual, because I do not include the experiment in the pre-lab discussions. I only have the calculation part of the lab manual. So after you have the mass of the zinc and you have the mass of the iodine, your first step would be you're going to change the gram to moles. And how do you change the gram to mole? Is going to be you use the molar mass, use the periodic table, and change the gram to mole. When you have the mole, or you have the mole for each one, basically you have the mole ratio. If it's not the lowest mole ratio, you find then lowest mole ratio. To find the lowest mole ratio, you divide both numbers by the smaller number to get the lowest. After you have the lowest ratio, you want to have a whole number. So if you want to have the whole number, you want to make sure that if it's not a whole number, if it's close to whole number by 0.1 or less, you just round it up. And if it's 1 to 1.5, you multiply by 2. If it's 1 to 1.33, you multiply by 3. If it's one ratio of 1 to 1.25, you multiply both number by 4. So if you multiply both of them by 4, you get 4 for this one, and you would get 5 for the other one. So you would get the whole number ratio. So how would you find, this is an example in the pre-lab, so I'm not going to solve it for you, but I would say just how would you start with this? What are your steps? The empirical formula for compound that is composed of potassium, chromium, and oxygen. the percent is given. So you are going to change the percent to gram. That would be the first step you're doing. Change the percent to gram. And after you change the percent to gram, find the mole for each. So 1, change it to gram. 2, find the mole. Step 3, you find the lowest ratio. So you find the lowest ratio. How to find the lowest ratio? You divide all the mole numbers by the smallest one. And then 4, you find the whole number. And to find the whole number, you are going to use the multiply by 2, by 3, by 4 until you get the whole number.